In Chapter 10, we will be discussing nuclear chemistry, which is used extensively in medicine both therapeutically and for imaging. Remember from Chapter 2 that isotopes are atoms of the same element that differ only in the number of neutrons. The atomic number Z is the number of protons, and the mass number, symbolized by A, is the sum total mass of protons and neutrons, so that the difference of the two, A minus Z, gives the number of neutrons in the isotope. Pictorially, here are the three main isotopes of carbon. Carbon-12 has 6 protons and 6 neutrons. Carbon-13 has 7 neutrons, and carbon-14 has 8 neutrons. They all have the same number of protons because the number of protons gives the identity of the element. Isotopes that spontaneously emit energy from their nuclei are called radioisotopes. This emission of energy happens because the nuclei are unstable and tend to become more stable upon the loss of radiation. This is what is meant by the term radioactivity. We will discuss 4 types of radiation: alpha, beta, gamma, and positrons. Alpha particles have a mass number of 4 atomic mass units and a charge of positive 2. This means the alpha particle is really a helium nucleus. It is the lowest energy particle we will discuss. Beta particles are high energy electrons. They have no mass, but they do have a charge. We symbolize a beta as an E with a 0 mass number and a -1 atomic number. This, as we will see, is useful for balancing nuclear equations. Beta particles are formed when a neutron decomposes to a proton and the beta particle or the electron. Similarly to the beta, a positron is the anti-electron. It is a member of the antimatter family. Positrons have negligible mass, but they have a positive 1 charge. We symbolize it much like the beta with the E and 0 mass and a positive 1 atomic number. Positrons occur when a proton is converted to a neutron and a positron. Both the beta and the positron are higher energy than the alpha particle. Gamma radiation is the highest energy radiation we will talk about. These are high energy photons. They have no mass and no charge. Therefore, when we symbolize these, we just use the Greek letter gamma. This table symbolizes the different radiation types we will talk about. It is good to know how to show the symbols, either the Greek letter or the atomic notation for each of these. Radioactivity is a scary term to most people because they have a poor understanding of what radioactivity is and what it is not. Radiation can harm living tissues and cause cancer. It can also be targeted to kill cancer. Radiation exists all around us and is a natural part of the environment. For example, bananas are radioactive because they contain potassium, which has a radioactive isotope. Radiation is also used in food preservation, which kills bacteria and organisms that cause food spoilage. But there is no residual radiation from this process.